Hi everyone. We are still in the introductory topics leading to your Calculus 1 course. In this section, we're going to focus on basic functions and more particularly on parabolas. A parabola is also known as a quadratic function. Traditionally, the relationship y equals ax squared plus bx plus c is used to represent a quadratic function in R2. Any point P of the parabola must have coordinates xp, yp that satisfy this relationship. In other words, if you replace x by xp and y by yp in the equation, you must get a true equality. In this video, we're going to focus on some specific characteristics of the parabola, which depend on the values that a, b, and c will take. Let's start with the importance of parameter a. The parabola has the shape of a smile, also known as concave up, when a is positive, or of a frown, known as concave down, when a is negative. We won't discuss what happens when a equals 0 because in fact we wouldn't have a parabola anymore, but simply a line. Here's an example of a parabola with an a value that is positive. Here a is 1, and notice how the shape of the parabola is concave up, so smiling. Whereas with an a value of minus 2 in this second example, the shape of the parabola is frowning, so concave down. The highest point, if a happens to be less than 0, or the lowest point, if the parabola is concave up, is called the vertex, and it always occurs at the x component equal to minus b over 2a. The parabola is perfectly symmetric with respect to its vertex. In other words, the vertical line, x equals minus b over 2a, will act as the parabola's axis of symmetry. The corresponding y-coordinate is obtained by substituting x equals minus b over 2a into the equation in order to find the y component. Here's our previous example where y is equal to 1x squared minus 2x plus 2. To identify the location of the vertex, we would simply have to calculate minus b over 2a. So minus b itself is minus 2, over 2a is 2 times 1, with an end result giving you a value of 1, which you see agrees with what the picture is providing. In the second example, y equals minus 2x squared plus 3x plus 4, we are looking at a parabola that is concave down and therefore has a maximum point. And this maximum point, this vertex, occurs when x equals minus b over 2a once again. So 3 is the b value, so minus 3 over 2a is 2 times minus 2, and result is that x is 3/4, which also matches the picture that we have. The zeros, or the x-intercepts of the parabola, can be found by setting the y value to 0 and by factoring the resulting quadratic equation. If it's not possible, you can also go by completion of square or use the quadratic formula in order to find the zeros. A quadratic function may have 2 zeros, but it may also have only 1 or even none depending on the location of its vertex and its orientation. Finally, the parabola's y-intercept always occurs at coordinate point 0c. It is found by setting the x value to 0 and by solving for y. For example, find the main characteristics of the quadratic function y equals minus 2x squared plus 5x plus 7. Let's start first of all by examining the sign of a. In this case, a is minus 2, so negative, and therefore the parabola will be concave down. The vertex will occur when x is minus b over 2a, So minus 5 over 2 times minus 2 provides us with the x-coordinate of the vertex, so 5 over 4. The y-component of the vertex is obtained by replacing 5 over 4 into the rule given by the function's equation. We find 81 over 8 to be that y-component. So the vertex occurs at 5 over 4, 81 over 8 in terms of its coordinate position. Being concave down and with the vertex above the x-axis, we would expect to have two zeros, both of which will be symmetric to 5 over 4, which is where the vertex occurs. If we let y equal 0, then we would have to solve the equation 0 equals minus 2x squared plus 5x plus 7 in order to find the zeros, or the x-intercepts. We're going to use the sum product method if it's possible. It actually turns out here that the two numbers m and n we would like to find must agree with the a times c element, so minus 14, and also with the b element, which is 5, and numbers minus 2 and 7 actually accomplish both of these criteria. Given that 0 is the y component at the x-intercepts, then we have used the sum product method to decompose the middle term, the 5x term, into minus 2x plus 7x in order to be able to perform factoring by grouping. In the first pair, minus 2x is a common term, and in the second, 7 is a common term, which we factored, which reveals also a common x plus 1 left behind in each pair. X plus 1 can then be simply factored to the front, with minus 2x plus 7 remaining. So the zeros are the numbers that would turn either of these factors into zeros. So x equals minus 1 would create a 0 in the first factor, 7 over 2 in the second, and therefore those would be the x-intercepts, or these would be the x-components where the parabola crosses the x-axis. The y-intercept will occur at 0, 7, since the c parameter of the equation of the parabola is simply a 7. Okay, so let's put all of this information together. Here's what the parabola would look like. And now just to make sure that it agrees with what we found, we've got a vertex that is above the x-axis at a height of 81 over 8, so just over 10, with an x-component 5 over 4, so 1.25. The zeros, minus 1 and 0, 7 halves 0, agree with the numbers we found earlier and match what the picture is showing. And finally, we have our y-intercept at 0, 7. So typically, if we were graphing this parabola, we would have created or located the vertex, the zeros, the y-intercept, and then sketched the parabola through those points. Here's a second example. Let's find all values of x such that x squared minus 4x minus 8 is less than 0. This is a type of problem we would have dealt with in the past when we solved inequalities. This time we're going to answer this inequality, or find the solution to the inequality, by visualizing the parabola whose equation is y equals x squared minus 4x minus 8. It's definitely concave up, considering that a is 1 and therefore positive. The vertex will occur at an x-coordinate obtained from minus b over 2a, so minus 4 over 2 times 1. So the x-coordinate of the y-intercept, of the vertex, will be at 2, and the corresponding y value is obtained by replacing 2 into the parabola's equation to get minus 12. So the vertex is located at coordinate point 2, minus 12. Therefore, this is below the x-axis, and considering the parabola is concave up, we will find two zeros on either side of x equals 2. Setting y equal to 0, the zeros must solve the quadratic equation that results from it. You'll notice this time that the sum product method cannot be used. You will not find two numbers that multiply to give -8 and also add up to give -4 very easily. So we're going to factor this polynomial, or this quadratic, using completion of squares, and afterwards by the quadratic formula, just to see the comparison. Okay, so if we are using completion of squares, then our first focus is on the coefficient of x, in this case a 4 or a -4. So remember that to complete a square we would have to take half of 4, which is 2, square it to get 4. That would be the number we would have to add to the first two terms to get a perfect square, or perfect squared trinomial. Adding 4 also forces us to subtract 4 to maintain the overall value of the expression. Now we'll join the first three terms together and express it as a perfect square eventually. -4 and -8 are regrouped to form -2. And here we go, we've got x minus 2 squared, which in expanded version would reproduce the x squared minus 4x plus 4 we had previously. Now if you remember, x minus 2 squared minus 12 actually is a difference of squares. It's not a pretty one, but x minus 2 could be treated as the a element and root of 12 as the b element in what we used to call a squared minus b squared from our difference of squares formula. So notice that we have simply applied the difference of squares formula to get the two factors that appear a little bit below. And since 12 is 4 times 3, there is a little bit of simplification that we can bring to the root of 12. Now the zeros are the values of x that would cancel off either of these factors. The first one is cancelled off with 2 plus 2 root 3, and the second with 2 minus 2 root 3. You'll quickly notice that these are equally distant from x equals 2, which is where the vertex was occurring. If you're using the quadratic formula, then it's much more computational, but quite direct actually to find the zeros. So minus b plus or minus square root of b squared minus 4ac all over 2a is applied by using an a of 1, a b of minus 4, and a c of minus 8. And computations will lead us to the exact same zeros we found earlier by completion of squares. Here is a graph of the parabola. The vertex is located at 2 minus 12. We have located the positions of our two zeros equally distant left and right from the vertex. The a value was positive, which explains why it's concave up. So solving x squared minus 4x minus 8 less than 0 is equivalent to finding all x values where the parabola is strictly below the x-axis. So from the picture you can tell that that occurs between the zeros. So the inequality is solved for x's that are within 2 minus 2 root of 3 and 2 plus 2 root of 3